Okay, we are in now chapter 8. And chapter 8 is an extremely important section. Some of the material you're going to learn in chapter 8 dealing with Taylor and Maclaurin series, which will come up later. That's what I consider to be some of the most important material in mathematics because it comes up again and again and again in courses. But before we can get to series, we have to understand about sequences. So I'd like you to copy this example down, and we're going to try to find formulas for each of the following three sequences. A sequence, incidentally, is an ordered list of numbers, that behaves according to some pattern. Okay, and when we find well, all right, let me let you copy this. All right. Okay, so all right, we have these three sequences here, and let's look at the first sequence. So for the first sequence, when they say they want you to find the formula for the first sequence, what they're calling the formula is known as the nth term. So we can think of a formula here. Hold on. Oh, I just got to change that point font. Okay, a formula is called the nth term. Okay, and sometimes we call it the general term as well. Okay, all right. So if we look at the first sequence starts at a half, and then next term is 2/3. So the half is a sub 1, 2/3 is a sub 2. Okay, so this is how we denote terms of the sequence. A sub 1 is the first term. A sub 2 is the second term. 3/4 is the third term. A sub 3. Okay, and if we Well, what would the next term be for sequence A? What would the next term be? We have a half, 2/3, 3/4. What's next? Good, Tosh. 4/5. What's next? Well, what's going to go on top? What number? 5. And then on the bottom, that's right, Javier, 5, 6, and so forth. So, you know, we have all these terms, but what we want to know is, what's the nth term? What's the nth term? What's A sub n? Okay, what's A sub n? That's right. Good, Taj. Good. So the nth term here is going to be n over n plus 1. That's and that is where n goes from 1, 2, 3, and so forth. That's the answer. Okay. Again, this is a comma here. So the terms of a sequence, we normally start off with the first term, you know, n equals 1. Second term, n equals 2. Third term, n equals 3, and so forth. Okay, so that's the answer for the first one. Are there any questions on that? All right, well, let's take a look at the second one. Let's take a look at the second one, second sequence. So second sequence, the first term is negative 2/3. Second term is 3/9. Third term is negative 4/27. The fourth term is 5/81. Okay, so I mean, what do you notice about like the denominators? What do you notice about the denominators here? The 3, the 9, the 27, the 81. You know, if I'm trying to figure out a formula, all right. So Jameson, well, what's involved with 3? What number seems to be common to 3, 9, 27, 81? 3. That's right. 3. So if I were to start writing down a formula here, okay, if I were to start writing down a formula, in the denominator, I would have 3 to the n power. 3 to the nth power. Now in the numerator, we have a 2 here, 3 here for the second term, 4 on the third term, 5. I'm not worried about the minuses and the pluses yet. We're just worried about those numbers, just the whole numbers on top there. The whole numbers on top. So what do you think? What do you think about that? What would we have to put in the top part of the formula to reflect 2, 3, 4, 5, 6, 7, 8, 9? What's going to go there? That's right, Jason. N plus 1. Very good. N plus 1. And 3, well, we have to, so we'll put n plus 1 here in the numerator. But now we have to worry about these terms. So we have a negative, the first term's negative, second term's positive, third term's negative, fourth term's positive. It seems that the odd terms you know, the first term, third term, fifth term, seventh terms. The odd terms are negative, and the even terms, you know, the second term, fourth term, sixth term, and so forth, those terms are positive. So we have to put something in the formula here that's gonna oscillate back and forth between negative and positive numbers. So I need to put something in my formula to do this. Something in my formula to do that. So let me ask you this. What if I were to put this in? What if I were to put -1 to the nth power? Would that do it? -1 to the nth power? Would that work? So I'll just mention, we know that n plus 1 is going to be correct on the top. 3 to the nth power is correct on the bottom. So if I had -1 to the nth power, the first term would equal -1 to the first power. So I mean, that'll work. I don't want to get too complicated here, but like what I'm trying to say is this. Let me try to make it clear, a little more clear here. Okay, so for B here, like if you have -1 to the first power, that's going to get you -1. -1 to the second power is going to get you +1. -1 to the third power is going to get you -1. And so you see, we're getting the negatives where they need to be, and we're getting the positive terms where they need to be. So this is correct then. This formula here, I'll highlight it in green. This formula is correct for number 2. So, you know, we're doing here solutions, right? These are solutions. We have the solution for A. We have the solution for B. Are there any questions so far? Who's feeling good so far? Well, Jinxon, there are different formulas possible. So like, for instance, what Jinxon's saying is, would, like, for this, for B here, for B, okay, would this formula work if you had the nth term is equal to negative, if it equaled -1, sorry, n plus 1 on top divided by -3 to the nth power on the bottom, would that formula work? It would, because that formula is the same as this formula. They're the same. So it would. There are different formulas. You can get different answers that are correct. You can get different answers that are correct. Okay, and I think, Javier, you're basically saying the same thing, right? If I'm reading that right. Yeah. So okay, well, very good, very good. Well, now let's look at the third one. The third sequence here, okay, is equal to, well, it goes 5 1 5 1 5 1 5 1 5 1, and that sequence is a little bit hard to get the formula for. So what I'm going to do is I'm going to go right to the answer on that. Okay, so this is now the answer for C. What I did was I recognize, well, let me just, we recognize that the terms, if we were to draw the sequence, see, we could draw it where n is on the x-axis, and then we plot the values of the terms on the y-axis. So, for instance, when n equals 1, you get a 5 up there. When n equals 2, the second term of the sequence is 1. When n equals 3, the third term of the sequence is 5. That's plotted with the dot up there. The fourth term of the sequence is again at 1. So you see you can plot dots. And you notice that between 5 and 1, is the number 3. So 3 is halfway between 5 and 1. Okay, so if you notice 5 is 3 plus 2. The first term is 3 plus 2. The second term is 3 minus 2. The third term, 5, is 3 plus 2. The fourth term, 1, is 3 minus 2. So basically, this formula here, the nth term being equal to 3 plus 2 times negative 1 to the n plus first power. It has to be n plus first power because I mean, if I just write, you know, like a sub 1 would be 3 plus 2 times negative 1 to the 1 plus 1 power. That's 3 plus 2 times negative 1 squared. And that's going to get you 3 plus 2 times 1, and that's 5. So that checks out. The second term would be 3 plus 2 times negative 1 to the 2 plus 1 power. Well, that equals 3 plus 2 times negative 1 to the third. And that's just 3 plus 2 times negative 1. And that gets you 1. So this formula is going to work. And I wanted to do that one because I figured that, how many think the third one is maybe the toughest? The third sequence is the hardest one to find a formula for. I agree, Ange. I agree. All right, so take a moment to copy that down. Take just a moment. Let's see, Taj. Yeah, traditionally, Taj, the sequence always starts at n equals 1. Now, are there exceptions? There can be, but like for web assign for your homework, and section 8 homework, I still need to get that ready, but I will. That's the one that's due on Monday. Section 8.1 homework due on Monday. I'm sorry, Tuesday. They generally assume that the formula you get starts at n equals 1 for the formula you provide. Good question, Taj. Good question. All right, are there any questions before we move on here? We have just a little bit of time, but it's enough time for me to mention what this other thing I need to mention here. Section 8.1. All right, let me for good, let me go to the whiteboard. Okay, and let me clear this. Okay, so next question I want to ask here is, does the sequence no, does the sequence given by this formula, a sub n equals n over 2 times n plus 1, does this sequence converge? Does it converge or diverge? Now, if a sequence converges, you've seen convergence already with improper integrals. If a sequence converges, that means the sequence reaches a limit. If the sequence converges, then the sequence, as n goes to infinity, the sequence will reach a limit. If the sequence diverges, that means as n goes to infinity, the sequence does not reach a limit. So what we can do for this problem is, well, we can write out terms of the sequence. Okay, and I want to do this in an intuitive way so you get an intuitive feel. We can always use algebra and stuff, but let's just sort of be intuitive here. Let's write out the first 4 terms of the sequence, or maybe 5 terms of the sequence. What's the first term of the sequence? First term of the sequence is when n is 1, and yes, I agree, that's 1/3. Good, Taj. What's the second term of the sequence when n is 2? Good, good, Ange, good, D'Angelo, 2/5. What's the third term of the sequence when n is 3? 3/7, good, D'Angelo. Okay, so 3/7, I'm getting that by taking 3 and then taking 2 times 3 plus 1 in the denominator. That's the formula, right? Okay, what's the next term? 4/9, good, Ange. And then the next term, the fifth term? 5/11. Good, Taj. All right, and this sequence keeps going. Keeps going. So this sequence, do you think it converges? Okay, what do you think it converges? What do you think as n? That's right, Taj. As n goes to infinity, the sequence approaches 1/2. So this sequence converges. So in your homework for section 8.1, you're going to have problems where you try to establish, formulas for sequences, and then you try to establish if the sequence converges or diverges. And although we can get into algebra and all that, I think it's intuitive to try to, just write out terms of the sequence, or we could graph a sequence too. We could graph a sequence in Desmos as well. So I'll just bring up in Desmos. There's a site here. Let me just I'll bring it up. Okay, I'll bring it up here real quick. One moment. Hold on. I'm trying to find out where I'm at here. Hold on. Got so much stuff open. Okay. All right. So is everybody good with this? I just want to go in Desmos for a moment. real quick here because I know we're at the end of our class. All right, if we're good, all right, let me go into Desmos. Okay, where is it at? Yeah. So you see here they, let me see. Let me just see here if they, let me try one thing, class. Hold on. I was hoping, hold on, will it show the thing? Yeah, this is what I wanted to, yeah. See that? There's a sequence, -1 to the nth. See how that -1 to the nth power, well, they have -1 to the x power divided by x. But you could write that, of course, the sequence would be -1 to the nth power divided by n. And they show there in Desmos, they show how to graph the that sequence. And so you can use that as a guide to help you with graphing sequences. What I'm trying to say is, if you go into Desmos, if you say like Google Desmos, graphing sequences in Desmos, you can learn how to graph a sequence. And you can really, like, there's sliders and everything to help you graph the sequence. So that can be very helpful. And, if you click on the dots, it'll show values. So this sequence was a different sequence than the one I just showed you in whiteboard. But I just wanted to bring it up so you can see that Desmos can be very helpful to graph sequences, and then you can see what the limit is if the sequence converges. How many think they might use Desmos to help them graph sequences? How many think they might do that in section 8.1? Okay, Javier, Mike, Jan, and Ange, and D'Angelo, wonderful, wonderful. All right, so, and Ethan, excellent, excellent. All right. So are there any questions before I stop the recording here? That's really, we'll talk a little more about section 8.1 on Tuesday, but this is enough for me to give an assignment for you. And, I think you'll be okay. Any questions? Okay, I will stop the recording.